Everyone, welcome to my video on embedding and similarity search. In this video, I'm going to talk about some of the most important concepts that are foundation of RAG, retrieval augmented generation. In this video, I'm going to talk about how to find the embedding for your model, for your sequence of text, and how can you do the similarity search using FAISS, Facebook AI Similarity Search. This is quite important because I use open source models. My favorite model is BGE. Right? So BG is for Beijing Academy of Research. Fascinating models. I use BGM3 because it has the largest context length, actually. So how much text you can fit to that at a time. But there are BG version 1, there is a BG English version. They're all great. It's just different from the based on the context length. This is the largest one, 8,192. All right. So let's start. So the first thing you need to do is to install a couple of necessary libraries. Sentence transformers to get your embedding model. The transformers, I installed it to get an auto tokenizer. I think it's already installed in the Colab. Depends on which version of Colab you have. But I think it's already installed. And the FAISS. So if you just don't write the FAISS-CPU, it gives you error message because there is no such a package. You can either install the FAISS-CPU or the FAISS-GPU. Both of them fine. By the way, I'm using Colab and I'm using the free GPU given in Colab. It's a Tesla T4. All right. So here I'm gonna import the necessary libraries, the sentence transformers. You see auto tokenizer. I'm not using this one. I'm gonna use this one for my next video, which is about the text generation. All right. So import files, and so here I'm gonna import a recursive character text splitter to split my text to more to smaller chunks. All right. So it's going to be very important when you have a very long text. And at the same time, when you go with the concept of RAG, when you ask a question, for example, who was this character? You don't want to return a chunk with 1,000 tokens. You want to get something with maybe 200 tokens, 300 tokens. You want only the answer to the question, a specific answer. You don't want the entire paragraph. So you need to actually split your text. This is also another one, character text splitter. But my advice to you, this recursive character text splitter is better than this one. You can always use this one, actually. Whichever you want to use, it's just in this video, I'm going to use recursive character text splitter and also the pandas. All right. So then what I did as well is that let me run it one by one. So this is the some text that I chose from Wikipedia. The first text is from the YouTube. So I went to Wikipedia and type search for YouTube, and I copy and paste parts of it here. The next one is for Instagram, about Instagram. The next one is about FIFA World Cup, right? So who won the FIFA World Cup 2022? And then, for example, this is for who hosts, which country hosts 2026 FIFA World Cup, and the last one is about Lionel Messi. I just search Lionel Messi. All right. So this is just I get some open source text. All right. Now, the next part is that I'm going to go ahead and load my model. So you see that I call it embedding model. This BG is the encoding model, which is used for embedding, right? Later on, we talk about the llama, and we talk about the model like Phi. We talk about you have perhaps heard of a model like GPT. These are the decoder only model that are used for text generation. And then we have an encoder decoder model that are like BART, FLAN-T5. They are actually for sequence to sequence type of prediction. All right. So I'm using this BAI BGM3, which is a super strong model. This is for the Beijing Academy of Research. And this address, I got it from the Hugging Face. So if you go here and type Hugging Face BGM3, you go here. All right, so I just copy it here. That's how I got that. And that's how I got the address. So you load the model. This is gonna take something around maybe maybe a minute to load this model. And the loading of the model is usually done in the CPU. All right, so this is a very big model, by the way. It has a context length of 8,192, which is, I think, even higher than OpenAI, I think by 1 token, higher than OpenAI. And then also the context line is big, and the size of embedding, we're going to look at that. It's 1024, which is very rich embedding, as opposed to some of this MPNet model. There are 512 or 378. So this is actually a pretty strong model. All right. Next, I'm going to actually get the tokenizer. So tokenizer to get some statistic, how many tokens my text has, and also see, for example, if the entire text is going to fit in the entire context length of my model or not. When you look at a lot of people talk about, or at work, when I look at many people actually work with these models, open source model, they don't really know what they are doing, to be honest. They don't really, for example, look at the context length of the model. They don't really know how many tokens they have. Sometimes they get the number of character and they multiply by 4 or they multiply by 3, right? This is not really a good way because some of these different tokenizer encode different word or different text differently. So you need to actually formally get the tokenizer and actually tokenize your text and then get the length of that. All right. So now here I'm gonna go ahead. So for example, get the first text here, Wikipedia, the first one, and then let's take a look at this one. All right. So the first thing I'm gonna do here is this is my tokenizer. All right. And then the 0 1 is the first text here. Is this one, all the way up to here, the comma. I just want to say how many tokens I have. All right, very good. So one thing before that is that if you get your text, the first one, and then you split it, the default is byte space. It tells you how many words you have in it. So I have 992 words. Now let's see how many tokens do I have. Let me. I have 1412 tokens, right? I have 992 word, 1412 token. There are different ways you can do that. Let me actually show you what you get together. It's very good to have a intuition on this stuff. So if you look at the tokenized text and just print it, let's see what you get at the end. See, if you work with this large language model or with these models in the past, you know that every time that you tokenize your text or sentence, you get the input IDs and you may get attention mask as well. There you go, attention mask, right? Okay, good. So here, another way to get this is that you get the input IDs here. It's a dictionary, right? Just go ahead and get input IDs and then you can get the length of that. That's another way to go with this. It should return. There you go. They are the same thing. Then that's what I've done here. So we have around 1412 token. All right. What's the context length of my model? 8192. So if you go to the BGE M3 page in the Hugging Face, you can actually find this one here. It has 8192 tokens. All right, which is way above the number of tokens that I have here. So I can fit the entire text into my model. However, as I said, you want to actually develop when you develop a RAG or when you come up with any model for the similarity search, what you want to do is that when you ask a question, you want to get an exact answer. You don't want to get the entire paragraph. You don't want to get 1400 tokens back. You want to get maybe 200, 300 tokens, right? To be able to verify the text, to be able to, because otherwise you can get the entire token. I know the answer is there, right? But I want to see which paragraph is my answer in, which sentence actually has contained my answer. So that's why, although I know that the entire model can be fed to the entire text can be fed to my model. However, so that's a good thing, right? However, it's still important to be able to split the text to the smaller chunks. All right. So here, I just actually try to show you how to embed. How can you embed the entire text? So here, let me embed the first element in the list here. So the way to embed is that when you get your embedding model here, you see your embedding model I loaded, you can go ahead and encode that. The function encode is gonna embed the text. All right, it's quite fast. All right, so this is the embedding, and now look at the shape of that. It's 1024. So it gets the entire text and convert it to 1024 number. This is what would be understood by the machine. All right. So this is the array of float 32, and these are the numbers that it generates. It may not make any sense to us, but it makes sense to machine. So machine, instead of that text that you saw, machine now understand this one as a representation of the text. All right. So what is this 1024? Is a dimension of embedding. Now we have one sequence in it, right? We have one sequence. If we have 10, the dimension is going to be 10 by 1024. We're going to see it. We're going to see this. All right. So now let's go ahead to the next section, and I'm going to split this text to the chunk of 300 tokens. All right. So let's look at that. So for that, I'm going to use the LangChain recursive character text splitter. You don't have to use this. You can write your own text splitter. But this one, in my opinion, makes the job very easy. So I'm going to use a chunk size of 300. So maximum, I'm going to by each chunk to have 300. I will talk about it, 300 tokens, and the overlap. So you know what? Let me go up and explain about this one. So let's say you have this one. Like, okay. So this is my text. This was 1400 tokens roughly. So let's say up to here is 300. Let me see if I can. Up to here it's 300 tokens, somewhere. Let's say 300 tokens up to here, right? And then I start again, then here become another 300 token. The problem is that sometimes the answer lies between these two chunks, in the overlapping part. If I don't have any overlap, I lose the context, right? So sometimes the answer is coming from this chunk and this chunk. It's somewhere between. So that's why in the recursive text splitter, we need to make sure that we have something called chunk overlap. Okay, so I put 20. Now, what is this? If you don't specify this function here, the default is len, which means a character. This means that this is going to be 300 character. This means 20 character as well. Therefore, I'm going to go ahead and write my own function here. I want the unit to be based on token, not based on word, not based on character. I want to be based on token. So look at what I'm doing here. You know, remember the tokenizer that I got? This is a tokenizer. I'm going to go ahead and encode my text, right? And get the length of that. That would be the way the tokenizer work, right? That would be the number of tokens when you get the length of this. So for example, let me see if I can show it here. If I can go ahead and get this one. I want to give you an example here. And this text is going to be Wikipedia 0, right? That's going to be this. And there you go. So it's 414.12, the same as before, right? It's literally the same as before. So that's how we can get you can use the same thing that we did here as well. I just found this one easier actually, right? So this is how you can get the number of tokens, all right? So when you put this here, the LangChain is smart enough, the recursive character text splitter is smart enough to say that, okay, I'm going to use this function and I'm going to respect these parameters, all right? So then I'm going to run this. There you go. So the next thing I'm going to do is that you remember every time I type my code, I use a Wikipedia text 0, right? However, if you look at this one, this is a list. I manually created this list. And this list, actually, you can get the length of that. For your data also, you can do the same thing. Wikipedia text, this is a list that has 5 elements, all right? So I want to do the same thing for all the 5 elements. I want to be able to split it to the 300 tokens because some of them can be very large as well. So I'm gonna go ahead and write a loop. This each string is gonna be each element of this. One of them was YouTube, one of them was Instagram, the other one was World Cup, right? Another one was Lionel Messi, right? So that's what I'm going to do, right? So originally it was 5. My list had 5 elements. So but some of the elements, remember the YouTube one was 1400 token. Now this one, each one is gonna be 300, is gonna be much more number because each text can be, for example, 5 chunks. Now let's see how many I have. 23. Let's take a look at some of this chunk together. So I'm gonna go with the all chunks 0. This is this. Let me look at this one. This is another one. All right. I'm gonna we can look at some of them, but I'm gonna show you something interesting here. Just please look at this one here. It would be very important to look at this one together. And the reason is important is because so I'm not. If you look at this one, first of all, you see that the text is actually much smaller than before, much smaller, right? So this is actually a more manageable chunk. Another one is that these are all belonging to the same text, right? If you look at the Wikipedia text 0, both of this is coming from the same chunk. And so this is actually quite important because now we got the bigger chunk and we actually split it to the smaller one. So now if you ask a question later on, I'll show you that. For example, the question is that, okay, you see this one, YouTube was founded by Steve Chen, Chad Hurley, and Javed Karim. Hopefully I didn't mispronounce them really bad, but YouTube was founded by these 3 people, right? So I don't want to return 1400 tokens only for this question, right? Okay. So let me see if there is anything else I want to actually tell you. I think this is actually pretty good. Okay, so yes, so let's see. Okay, now let's continue. So now that we have this one, now we have a good understanding of splitting text. Now we have a good understanding of the embedding the our sequences. All right. Now I want to talk about the similarity search. All right. So we look at this text here together. But one thing that we haven't asked ourselves is that in a RAG, usually you ask a question. RAG is for question answering, right? So RAG still has a text generation part that I haven't talked about that. But what if I want to see that based on only this text, based on these 2 texts here, who founded YouTube, right? Can I get this one back based on some similarity search? I ask a question, is there any way that I can match this similarity with the current text and see whether it can retrieve this text or not? The initial part of RAG, the retrieval part. All right, so for that we are using FAISS. So FAISS is the in-memory vector database, right? There are a lot of them. There is ChromaDB as well, but and there are a couple of more as a ChromaDB also is free. However, the FAISS, what I like about that is because one is super fast. Second one is that is actually in memory, and the quality of retrieval is very strong in my opinion, right? So for if you don't have many texts, which one I by many texts I mean I've used it up to 20 billion sequence. It still was quite fast. Here I have 23. It's extremely fast. But if you have in something in the order of trillion, I think this FAISS might be a slightly slow, and for that we can use different index. But for now, I'm gonna first walk you through the exact index. So the way FAISS works is that you need to first define your index. Then you need to add your embedding, the embedding for the entire text that you have. This is like your database, right? So let's say you want to ask a question. The idea is that what's your library? Let's say the library that is full of books, and you're asking question, and so the answer should be in one of these books. The library is a collection of all the books, right? So collection of all the texts. In the FAISS, you need to add the collection of the embeddings to your FAISS database. So what you're gonna do here is that you see, let me get the embedding of all the chunks first, right? So you do the same thing with the encode, and then you do all the chunks, which was 23 chunks. Now let's take a look at the dimension of that. It should be 23 by 1024. 23 sequence, 1024 each one. There you go. All right. So now the first thing you do is that you get a dimension of your embedding. Dimension embedding is this one, 1024. You define your index. You say that define the index based on the dimension of my embedding. All right. So for OpenAI, this is going to be 1536. Is a little bit more dense. And this is index flat LDO. This is Euclidean distance index. And this means exact search. So it's not approximate, it's exact. It's a very accurate search, right? And when you don't have many vectors in your database, this is actually pretty good. Once you have a lot of vectors, this could become a little bit slow. For that, we can use approximation. All right, so then we're gonna go ahead and add the index to add the embedding to my index. So this is the embedding model that we have. We're gonna add it here. That's it. After that, we are done. So now our database is populated by all the embedding. All right. So now what's the approach? The way it works here is that you have some questions. You have your original question. So first you define your index, add your embedding to your index, to your database, like FAISS. Then you have a question in plain English, for example. Let's say, for example, who owned YouTube? That's the question, right? You get the question, you embed your question. Remember, the similarity between embedding. In your FAISS, you loaded your embedding. You didn't load your original text. So when you do the similarity search, like cosine similarity whatsoever, is between embeddings. So you have to embed them. You embed your text, is here, is embed our text. And then we perform the similarity search. All right, so how do we do that? In any similarity search, like cosine similarity or any similarity search, the question is that, hey, let's say who owns YouTube? And I go through all the database, all the texts, and I find 10 texts that are very similar to this. How many of them do you want me to retrieve? How many of them do you want me to return to you? 1, 2, 10. This is K, the number of texts you want to return. This is also the embedding of the query. All right. And this is going to be the index. I is the index, D is a distance. Let me see if I can print D as well for you guys to see this. D is a distance. Right. So the lower, the better. The first one is a distance of point A, 0.8. This is the second one is 0.68. All right, great. Now, at the end of the day, okay, these are all good. What I care about that is not this. What I care about is the original chunk of the text. All right. So let's take a look at this one. The index is I0. I bracket 0, right? So I'm gonna loop through this one and return the part of a text, all chunks, remember? All right, let's take a look at this. So the first one is that YouTube is an American social media online video sharing platform owned by Google. YouTube was owned by Google. This is what we want. Owned by Google. Right? And this is going to be the second one. So you see the answer exists in this one. The answer exists in this one. So the first one. I think the answer to the question only appeared in one chunk. You specify 2. If you specify 1, it will only return this one. Let me just show you this one. Right, it will only return this one, the top one. We can try this one. Who found that YouTube? Does this one work? Right, so Who found the YouTube still is coming from this one, Steve Chen, Chad Hurley, and Jawed Karim, because it says that they founded YouTube. Now, if we go with two, this one now makes sense. Where YouTube was founded by Steve Chen, Chad Hurley, and then Jawed Karim, right? So you see this is very powerful. This is a foundation of RAG. The retrieval part is what we want for the RAG. You can try different model. I don't know who is Lionel Messi. It's coming from Lionel Andres Leo Messi, and then all the Argentine professional football player who plays as a forward for and captain is both Major League Soccer Inter Miami. So as of now, he's Inter Miami, right? So his Wikipedia is very updated. Born in Rosario, Argentina, Messi relocated to Spain. You see this one, right? So it's pretty actually good. So it's like as a foundation of RAG, in my opinion, actually, it's pretty good that you have this understanding that what RAG can do actually, right? So in the RAG, original RAG, we get this one and then send this chunk to the large language model for the actual text generation. All right, so that's it what I have for this video. Leave a comment if you have any question, and I do my best to respond to your question. Thank you so much, and see you all in the next video.